Good morning students. I hope you all are doing well. So in our previous class we have studied that different types of magnets are there like bar magnet, U-shaped magnet, horseshoe magnet and many others. So today I am going to show you some of the magnet. As you can see in my hands, this magnet is known as bar magnet. Alright, it's a bar magnet. Now these magnets, they are in U shape. So they are U-shaped magnet. Alright. So as I have told you that whenever we bring iron objects closer to a magnet, it always attracts the iron object towards it. So let's see. Here is a bar magnet. I am bringing iron object closer towards it. It attracted at one of its end. Similarly, on the another hand also it gets attracted, right? Similarly, in the case of U-shaped magnet, I am bringing the iron object closer to this U-shaped magnet. It attracts the iron piece towards it, right? Now, today we will study law of magnetism. Alright, today we are going to study law of magnetism. So this I am going to explain you via activity. Alright, so let's get started. As you can see, I have two bar magnets. They are identical bar magnets, right? They are identical bar magnets. So now one by one I am going to bring the like poles towards each other and then unlike poles towards each other. Now what is like pole and unlike pole? Like pole and unlike poles. So like poles, like means similar, like means similar pole, like north pole of one magnet and north pole of another magnet, or south pole of one magnet and south pole of another magnet. So similar poles, north north, south south, they are known as like poles. Now what is unlike poles? Means different poles. For example, north pole of one magnet and south pole of another magnet. Or we can say south pole of one magnet and north pole of another magnet. Okay? So this is like poles and unlike poles. So I have told you that in a magnet there are two poles, right? North pole and south pole. So you can see clearly that it has been mentioned here. N, capital N stand for north pole, capital S stand for south pole. Alright, so now what is law of magnetism? Law of magnetism states that like poles repel each other and unlike poles attract each other. Alright, we will be proving it also, but let's write what is law of magnetism. So law of magnetism states that like pole repel each other and unlike poles attract each other. So let's prove it. See, in my hands there are two magnets. Now as you can see, this is north pole of one magnet and this is south pole of one magnet, right? Means these two poles are unlike poles, north pole and south pole. Now what I am going to do, I am going to bring them closer. what happened? They get attracted, right? When I am bringing North Pole and South Pole towards each other, it gets attracted toward each other. Now we can repeat it with South Pole and North Pole. So here is South Pole, here is South Pole, and here is North Pole. Again, unlike poles, it attracts toward each other. Now let's repeat it with like poles. Alright, like poles means firstly we will be bringing North Pole of one magnet and North Pole of another magnet. Okay, now we are bringing closer towards each other. What is going on over here? As you can see, they are not getting attracted toward each other. They are just moving here and there. So these two magnets gets repelled. Alright, see, these two magnets get repelled. So similarly, with South Pole and South Pole, here is South Pole, here is South Pole. Again I am bringing them closer. See what is going on? These two magnets gets repelled towards each other, right? So this is what? This is law of magnetism, that the like poles repel each other and unlike poles attract each other. Alright, this is what law of magnetism states, that two like poles will always repel each other and two unlike poles will always attract each other. Now, suppose an object is given to you, an iron object is given to you, and you have to check whether it's a magnet or not. So what you will do? Or if anyone asks you that which is the surest test for magnetism, so what you will give the answer? Whether attraction or whether repulsion is the surest test for magnetism. So do remember, children, for test of a magnet, repulsion will be the surest test. Repulsion is the surest test for a magnet. So the reason is that magnetic attraction will always take place between a magnet and another magnetic substances, right? Iron, nickel, cobalt, etc. When they will be coming closer to a magnet, it will always attract. But magnetic repulsion, it will be only possible when the poles are like poles. When the poles are similar, then only repulsion will take place. Alright, so that is why it has been said that repulsion is the surest test for a magnetism. Now, here I am going to do one activity in which you have to prove that the substance, the object, is it an iron object or it's a magnet? Alright, it means that you need to identify whether a given object is simply an iron object or it's a magnet. So suppose these things are there, these two things are there, among which one is a magnet and one is simply an iron object. So how we can do it? Let's see. Suppose we have two bars, bar A and bar B. Alright, out of which only one is a magnet and other is simply an iron bar. You don't know which one is a magnet and which one is a iron bar. Now you need to identify that among both of them which is a magnet. So what you will do? Firstly, you will place the bar A on the table. Alright. Now touch one end of the bar B. Touch one end of the bar B to bar A. Now the other end. And at last from the middle. So you can see in all the three cases, what is happening over here? This bar B get attracted from both the end and at the middle as well. Alright, so then you can see that, you can say that this bar A is an iron bar because it get attracted from both the ends as well as at the middle. Now we have to repeat the process by placing bar B on the table and touching the bar A at one end, then towards other, and then at last in the middle. Let's do it. I'm touching it from one end, it get attracted. Now from another end, it get attracted. Now at last in the middle, it is not getting attracted. You can see it clearly, see? It is not getting attracted. So bar B, this bar B is a magnet. So from this activity we have seen that this is an iron bar and this is a magnet. So this is how we can identify whether a given object is an iron object simply or it's a bar magnet. Alright. One more thing, children. Do you know that magnetic poles always exist in a pair? Like as I told you, in a bar magnet there are two poles, north pole and south pole. So these poles, they always exist in pairs. It is impossible to separate these poles. It is impossible to separate north-south pole. Suppose you are going to break this bar magnet from the middle. You are going to break it. So what will happen? Here will be the north pole and here will be the south pole, right? So what will happen as soon as you are going to break it, immediately right after, the pole will automatically be created. Now like north pole is here, so here will be south pole. South pole is here, so here will be north pole. Again if you are going to break it from the middle, now what will happen again? Again you will be getting two parts from here and two parts from here, right? North, here is south, north, here is south. So immediately south pole will be generated over here and north pole will be generated over here. Similarly, south pole will be generated over here and north pole will be generated here over here. Same thing will happen each and every time when you are going to break it. Always and always poles will exist in pairs. Alright? Now, moving toward our next topic, that is magnetic field. So now let's see what is magnetic field. Magnetic field. So, what is magnetic field? The space around a magnet. Suppose this is a magnet. The space around this magnet in which magnetic force can be experienced by any magnetic substance like iron is known as magnetic field. Again I am repeating. Magnetic field is the space around which when magnetic substance such as iron is placed so that it gets attracted towards the magnet is known as magnetic field. Now one more thing I would like to tell you about the direction of magnetic field. So what is the direction of magnetic field? It will always be from north pole towards south pole. From north pole towards south pole, like this. It will always be pointing from north pole towards south pole, alright? And talking about the uniformity. So, the magnetic field is not uniform at all the places. Magnetic field will be strong near the magnets and it will become weak when there will be a distance from the magnet. Alright, so this is it for today. Now in our upcoming classes we will read about electromagnets, its application and so many more things. So thank you and have a nice day.